3. Welcome to the 37th webinar being hosted by the India Center at Flame University, Pune, India. We are extremely privileged and honored to host an eminent scientist and astronomy scholar, Dr. Shylaja from Nehru Planetarium in Bangalore. Welcome, ma'am. And let me read her bio and I'll invite her to then take over and deliver all the knowledge and wisdom that she's going to present. The title of her talk is going to be Ancient Indian Astronomy, Efforts to Achieve the Right Model of Planetary Motion. And her bio reads like this. Dr. B S Shylaja worked on the binary stars with Wolf-Rayet component for a doctoral thesis. She continued her research on comets, dwarf novae, and magnetic and metallic M stars. She has authored 150 research papers in astronomy and the history of astronomy. After joining the Nehru Planetarium in Bangalore, she engaged in educational activities, including teaching on weekends, producing sky theater shows, and conducting outreach. She worked on various interactive demonstrations and models and taught a range of age groups. Currently, she works on the history of astronomy in India, focusing on medieval period manuscripts, stone inscriptions, and temple architecture, almost all of which you will see in her talk today. Really blessed and really privileged to have such an innovative topic, an ancient topic, but with an innovative touch by Dr. Shylaja. Welcome, ma'am. And
Thank you.
You can now.
Thank you for giving me this opportunity to address your students and faculty here. So let me start sharing.
Please.
So I suppose the screen is visible?
Yes, ma'am. All good. Yes.
Okay.
You can start the show. Yeah.
Okay.
You can also do.
So
now.
yeah.
Perfect. Yes. Thank you.
So I'm now going to talk about the model of planetary motion as was understood by the astronomers in India from say about 2000 years or a little earlier. When we say model, we shouldn't be thinking that it is something similar to the mathematical models that are being discussed in the current environment. So this is much simpler than that. So when we say ancient, how long ago should we go? So when we look at the works of historians and science historians, we have to start with a person like Bal Gangadhar Tilak. And there were many contemporary British scholars who defined ancient to mean something like 1500 to 600 years before 1800 CE, their time. Now that is quite debatable, but they had to fix it at that because they were not aware of the civilization of Harappa and Mohenjo-daro at that time. Once these civilizations were discovered in the Indus Valley, then they had to change the perception of what is ancient, how ancient is our civilization thoroughly. And then there were people like Marshall, a British scholar, Kosambi, father and son duo, Devi Prasad Chattopadhyaya, R.C. Mujumdar, S.R. Rao, many more people who tried to date the Harappa and Mohenjo-daro civilization, and based on that, they tried to understand the evolution of the Indian culture, tradition, and other Indological studies. Of course, we have to remember lesser known scientists of the Archaeological Survey of India, very unassuming. They have done all the field work and a lot of contribution to this science. So Harappan or the Sindhu Saraswati civilization, we believed that it originated along the Indus, and there are so many sites now in Pakistan. Yes, there are a good number of them in Haryana, which is not covered here. And of course, Gujarat also, we have Dholavira, Lothal, and all these places well established for the culture, civilization which existed in those days. However, now we have to redo this analysis because very recently we have found a similar structure in southern India, in the Deccan Plateau in Karnataka, as well as in Tamil Nadu. And therefore, this is not just limited to the Indus Valley. Now we have to extend our study to the rest of India also. Now, as far as astronomy is concerned, where do we begin? Where do we call as the history of astronomy? As per the records available today, the oldest text that is available is called the Vedanga Jyotisha, and the date is not yet finalized. It has not been possible because those people did not have the habit of writing down the date when they wrote any text. So it ranges from 500 BCE to 1600 BCE. However, we have the other text, a very beautiful mathematical text called the Shulba Sutras. I'm sorry about the spelling mistake there. It is Shulba Sutras. From 700 BCE to there are 4 or 5 volumes of them, and each of them has been dated. And so we have the range from 700 BCE to 1300 BCE. They are basically mathematical details on how to construct a fire altar, what is called as a chiti. Geometrical discussion, geometrical patterns, and so on. But when we search for astronomical references, the earliest we get is only the Vedanga Jyotisha, and we know that it was built upon a very strong foundation based on the Shulba Sutras. Then there is this concept of Kalivarsha. So Kalivarsha is a very interesting number, and that is cited not only in the earlier references, but in the recent times, as recent as that of Aryabhata. We can consider, therefore, Aryabhatiam as a summary of the knowledge which was available prior to him. So here he states, he wrote this book Aryabhatiyam when he was 23-year old, and 3600 Kali Varshas had been elapsed by then. Now, basic question is, these ancient people, what did they see in the sky, and why was there a need to look up at all? Was there a need at all? Why should they look up at the sky? So they first started perhaps with the systematic observations of the sunset and sunrise. This is what you can presume that this is the easiest to observe. And comparison understanding of the relations with moon rise and moon set. This is another thing we will be able to jointly handle with the sun. These two objects in the sky are the brightest, and nobody can escape attention from these. Then there was a need for some application for day to day. So what could be that? So the travel, if they want to travel somewhere, they should know the time, they should know the direction, and they should know the location where they are. And other activities like hunting and fishing, this also requires some knowledge of the weather phenomena, periodic phenomena that is happening in the sky, the climatic changes, rainy season, and things like that. And for smaller time measures, as from today to next week, or today to 5 days more, moon phases would suffice. So moon phases also were being used as a time measure. And of course, gradually as they picked up agriculture and cattle rearing, the life cycle of the cattle, the pattern of agricultural scheme, all these things needed some kind of a time measuring device. So the sky was the one which was easily available for them. So they depended on that. We see traces of this in many cultures. For example, there are marking on eggshells. They have been acquired from Italy. Then on bones, pieces of bones, they have marked moon phases like this, as is shown here. And then we also have many rock art like the one we see in Bhimbetka. I will show a couple of examples of that. Once they were able to express themselves with words and the language was developed, Then we have the oral tradition of the folk tales and mythological stories. Still, we are left with many unresolved patterns that we see in the seals of Mohenjo-daro and contemporary seals. So here, for example, this is the one which is called as Pashupati, and there are some marks here on the horn. So this is understood as the phases of Venus, not moon, phases of Venus. And these seven women here have been called as seven mothers, which is now brought forward as Saptamatrikas. So this is the way some mythological tales and folk tales had some kind of a link. These drawings had some kind of a link to what they saw in the sky. So let's imagine ourselves to be around 4,000, 5,000 years ago, and let's start what they would have done. Let's imagine what they would have done. So they notice that this position of the sunrise changes from month to month over a period of 30 days or 40 days. So we will start marking when it goes to the extremes. So this is our position here at the center, and let's say, and we put a marker for the sunrise here in winter. Similarly, on equinoxes when it is midway, and then sunrise here. So these kinds of markers we put in the first year. In the next year, we put another marker so that there is an alignment. And if you stand here at the center, you will be able to easily say that this is the direction of sunrise. And it takes approximately 365 days for the sun to come back to this position. So this is the kind of simple arrangement they had, let's say, in the beginning. I'm showing this because we have ample examples of these kinds of alignments to winter solstice and summer solstices scattered all over the country. I'll show some examples later. Now let's repeat this for the moon. It will be slightly different. So you have the southernmost point of the moonrise and moonset here, and therefore the path of the moon is slightly different from that of the sun. So this kind of an idea comes. So when is the moonset and sunset coinciding in this direction? And when that is, which time of the night it happens, which time of the year it happens, a systematic observation of this would have led to a calendar. So this is how the calendar started, and now you know that the calendar system is one of the perfect systems that we have now, especially if it is based on these astronomical phenomena. So this is how it is marked. These are the examples of these kinds of stone structures in Karnataka. So Brahmagiri is a place, small place, and it's in near Chitradurga. It's in Karnataka. So these are the stone structures, and the alignment was first noticed by Marshall, and this is the place where he saw it. And subsequently, this is the drawing he prepared. And very recently is 1993, Kameshwar Rao, my colleague, he went and studied this area and arrived at the possible link of this to the sunrise and solstice, sunrise and sunset at solstices, and a similar kind of an arrangement as I showed in the pictures before. So this is another interesting thing in South Africa. This is called the Chariot of the Dying Sun, and this is on a hiking track on a mountain. And here also you see some kind of a stone pattern. This is the map, and this is the one for the sun, and this is the one for the moon. And so this is the on the spot view here. You see the stone structure here and this mountain here. This is the mountain which is aligned for winter solstice sunrise. So this entire thing has been constructed in this. And this is in Swaziland, in South Africa. Interestingly, the names of these are all Indian. So the person who sits at the center is called Suri. Suri is a Kannada word. And this is called Chanda, which is probably derived from Chanda, Chandra. and so on. So the 5-degree difference in the orbits of the sun and the moon is very clearly implemented here. There are many other words here that are listed, and they all are sounding similar to Indian, especially the coastal regions of Karnataka, Goa, and these places. So they claim that some historians claim that these were built by the Indians who were traveling there before the colonial advent. There was a regular traffic movement along the west coast to the Arab countries and then to up to Africa, and that is how these Indian people settled there. That's a different story. Now we have many more examples. I have picked up from Karnataka because I know the work of Professor Ishwarrao. So this is a place called Hanam Sagar, and you can see the alignment of stones. Although they have been disturbed terribly in this because they want to use this flat land for cultivation. So here you still see some remnants of the stone, huge stone structures which are distributed like this. He has made a thorough study of this, and this is still as it is. Even now you can go and see near Srinagar, a few kilometers in the outskirts of Srinagar. This is called Bur's home, and inside near this there is a pit, and the pit is empty. I'll show you what was in the pit a little later. So you should read papers by Professor Vahia, Danino, and Srikumar Menon, who have worked extensively on this topic, which is now recognized as archaeoastronomy. So essentially, they try to understand what's the relation between the sky and the earth. The simplest is that it is dependent on where you are on the earth. So sometimes you see that the sun rises here, goes in this arc, and sets here. And 6 months later, you will notice that the sun rises here and sets somewhere here. On the other hand, if you are at some other point on the earth, it may happen along these circles. And if you happen to be on, this is an extrapolation, if you happen to be on the pole, Arctic region, then the sun will move parallel to the horizon. So this is an indirect evidence on the spherical structure of the earth, which they somehow understood in a very indirect way, but this idea was carried forward to the next generations. I told you about Bur's home. Bur's home has a pit and there was a rock here. This is the rock. So did they observe the stars? I told that sun and moon would suffice for a calendar. Then why should they observe the stars at all? Or why should they observe the planets at all? So we have a proof that they did see the stars by this rock art here. It was in Burzum and now it is in Delhi. It has been moved from there. So you see that two stars have been clearly marked here. Why was this marked and what was the idea they were trying to convey? Whether they were trying to tell that the moon was eclipsed or the sun was eclipsed, or they saw two stars which were very bright, or they saw one star and the other star brightened to the extent of the same. We do not know of any of those things because other than this picture, we don't have any information. Sorry about it. Okay, so we have many indirect evidences on city planning, accuracy in fixing cardinal directions, and of course their excellence in geometry we see on pottery and seals, and their excellence, of course, I told you already about Sulva Sutra and the application of the so-called Pythagoras theorem 700 years before Pythagoras was born. And then the navigating techniques, what techniques they had for moving around. And interestingly, there are some indirect hints on the bricks also. So these are the examples of city planning. This is Mohenjo-daro and this is Lothal. You will notice that there is a perfect north, south, east, west alignment here. So is it here. The river is along this, the Bagoya River, but the canal was drawn here to the dockyard. But they maintained this kind of a perpendicular arrangement of the roads that you will appreciate here. So how did they manage this? They had some method of fixing it, looking at the sun. And these geometric patterns that you see on the pottery, beautiful. Even nowadays, if you want to do this, you need a compass and other things. So it means that they had tools of this nature, or even with free hand, they were able to produce these kinds of beautiful drawings. So Dholavira is a very interesting place in Gujarat. And if you happen to go there, don't miss going to the top of the hill and seeing this pattern there. This was studied particularly by Dr. Vahia and his group. And you see this kind of a funny structure here. Although all the others look like houses, this one is a circular one with some kind of a kink here. So they studied this pattern. This is how it is. And they found that this was perhaps the foundation of some kind of an observatory because it is aligned to the north exactly. So it is possibly relating to the astronomical observations they were doing and the results they were obtaining with that. Okay, now comes the interesting part on the size and shape of the bricks. Professor Balasubramanian, who was a chemistry professor in IIT Kanpur, he has done a lot of measurements on the Delhi Iron Pillar in the Qutub Minar. And so he was trying to understand the mathematical significance of the structures there. And he compared the sizes of the bricks from Qutub Minar, from Mohenjo-daro, and from any temple anywhere else in India. They all have identical sizes. So the size of the brick has been a standard right from the days of Harappa Mohenjo-daro till about a decade ago. Now the size of the bricks is slightly different for different reasons. Instead of this traditional method, they have gone in for other methods. So there is a difference. So this is another setup in Dhalavira. Now, another indirect evidence that we get is in the many books they say Vedanga Jyotisha and other things. They say Kritika was rising. Kritika is a group of stars. So all stars rise and set. So Kritika also rises and set. Then what is the special meaning associated with Kritika was rising? It means that this point which you call as Vishuva, where the equator and the ecliptic intersect, today we call it Ashwini. Ashwini is the starting point for any measurement on the ecliptic in the Indian system. Now, but some time ago it was Kritika, and that was recorded somewhere and it was interpreted properly. In this context, I should mention about the monumental work by Shankara Balakrishna Dikshit. He, as a single individual, compiled all available sources on astronomy during his time in the last part of the 19th century. So there were many forgotten manuscripts, and he tried to understand the influence of Islamic and European astronomy because by then the European method of education, the British system of education, was already setting in, and the traditional Indian method was almost lost. So he wanted to revive the interest in that, and especially in the context of astronomy. And this whole work was done by one individual. He single handedly managed this, and he first wrote in Marathi 2 volumes, and then later they were translated to English, and today they continue to be the only authentic source on any of these subjects. Most of my statements here are taken from his book. So he classifies that there are treatises, that is Siddhantas. So Vedanga Jyotisha is one which is contemporary of the Rig Veda and Yajurveda, or maybe other. So the dates of all these we do not know. We have Aryabhatiya, we have Brahmasputa Siddhanta, Pancha Siddhantika, Mahabhaskariya. These are all between 5th century and 10th century. Siddhanta Shekhara is 11th century. Karanapaditi is a little later. Now, these treatises says that an expert astronomer should possess, if you want to call yourself an astronomer, you should know these things. What are these things? Bhu Bhagana Brahmana. You should know the Earth's rotation and revolution. When I say revolution, they were not under the impression that the Earth is rotating around, revolving around the Sun, but they believed that all other bodies are going around the Earth. Even the constellations are going around the Earth. So, what's the difference between the rotation and this revolution? That you should know. Then you should have the location, your own location. Where are you on the Earth? Your geographical latitude and longitude. And depending on that, the duration of the day and night at different times of the year. And the astronomer should also be familiar with Sachara Dalakala, that is, the corrections you need to apply for the rising points of the zodiac, which includes the sun or the moon. The only tool they had was a stick. With the help of the stick, they would measure the shadow and convert the shadow into the corresponding astronomical units. It could be the position, it could be the time. So this an expert astronomer is expected to know. And Kshetra Kala Karana, that is precision in determining the exact time that is measured in units called ghatis, elapsed since sunrise or sunset. If it's a daytime thing, you measure from sunrise. If it is a night event, you measure it from sunset. So this ghati is equivalent to today's 24 minutes. So they had small devices which you will still find in temples being used as a ritual. Now, the interesting question is, Aryabhata, I showed you right in the beginning, he gave his year of birth. Why did he give the year of birth? He says that so many years have passed since Kali Yuga and I am now 23-year-old. The purpose is that after he has given some constants. After some time, you need to apply corrections to these constants in order that you use the same formula for any time, any place. So the Gitika is one of the chapters where he gives this, and this was interpreted by his student Lalacharya later in the 9th century, and subsequently emphasized again by another disciple, Suryadeva Yajva, in the 12th century. So what is this interesting correction? This is called the precision. We know that the Earth's orbital thing is inclined to the vertical by 23.5 degrees. And this itself changes. And so the point of intersection which we took as the reference point, this point itself is changing over time. The time period is very large, 26,000 years. But over a time scale of 100 years, you have to definitely make a correction. So this is the reference point here which we took. And so this is winter solstice and summer solstice. And as you see here, because the axis itself is precessing, the reference point itself is shifting and you need to apply this correction. So this is the way they suggested the corrections. That means they not only knew that the Earth is a sphere, they also knew that it has a rotation axis and the rotation axis itself is going around with a period of 26,000 years. Such ideas will be concealed into folk tales and mythological tales. And now it is very difficult to extract the meaning out of that. So we have to depend only on mathematical and astronomical texts like the Aryabhatiya. So there are several astronomers whom I have listed here, Aryabhata, Varahamihira, and so on. So the oldest text describes the calendar. The names of the months are based on the seasons and stars. So they were called as Madhu, Madhava, and so on. That defines only the weather phenomena. It's related more to the weather. So the names of the months, no, they believe that the earth is at the center and the sun and the moon both go around it. And the way they go around it, they had to have some markers in the celestial sphere. So they used 27 stars. These are the famous 27 stars. with which they mark the position of the moon. The same 27 stars can be used for the sun also. So, for example, when the sun is in this direction of this star called Revati, when the sun is setting, you will see that the corresponding star, which is 180 degrees away, Chitra, will be rising in the east. So, indirectly, they were able to infer the position of the sun in this system. Subsequently, the Madhu Madhava got replaced by Mesha, Vrishabha, Mithuna, which now we call as the solar months. Now, the details of the revolutionary period of the planets are all believed to be going around the Earth in the same reference plane. So, the same references can be used for them. So, all these will give the number of revolutions taken by these different planets, and they will give them as abbreviations or a long formula, all in verses. So the model, if you want to call it as a model, the easiest can be related to the sun and the moon. So they had the model of the earth at the center, and the sun is going round in an orbit like this, which is called the ecliptic Kranti Vritta, that's the name. And this is the orbit of the moon. So this is the orbit of the moon. The interesting point is that the two intersect here at a point which is marked as the node N1. That's the current convention. But what they knew was that the sun takes 1 year to complete this revolution. The moon takes just 1 month to complete this revolution on this orbit. And the node takes 18.6 years in the opposite direction. It moves in the opposite direction. So this is something, some imaginary point that is moving in the sky. They gave it the status of a planet and said that yes, this is the unseen planet, and that is responsible for the eclipses. Today we know that the detailed mathematical calculations involves all these things. We need to know the position of the node. So the eclipse essentials, what's the meaning of new moon and full moon? New moon is not a day, it's an instant. When the sun and the moon are in the same direction, same longitude, we can say. Full moon is, they're exactly 180 degrees away. That's the meaning of full moon. So why there are no eclipses every full moon and new moon? That requires the knowledge of that node N1, and that they called as Rahu. So the N1 and N2 which I showed have been named as Rahu and Ketu, and there are some mythological tales which will explain you the meaning of Rahu and Ketu, but mathematically this is the concept. So we need to get the positions of the sun and the moon very precisely, and we also need to find the speeds of the new moon and the full moon at that instant, of the full moon at that instant, and then revise the calculations the exact instant of when the new moon is happening, when the full moon is happening. And so this kind of a correction, this kind of a calculations, they need to do. So for fixing the position of this, they first assume that they are going round in circular orbits, and then they had to correct it. They corrected it for what we now know as elliptical orbit. Then all these books take Ujjain as the standard. All calculations are done for Ujjain. If you are not in Ujjain, then depending on your latitude and longitude difference, you have to apply the correction. And the moon is moving and the sun is moving, both are moving, so the relative speed correction also have to be applied. So the assumption they made was that all these bodies have the same linear velocity. When I say linear velocity, some kilometers per second. That is same for all of them. But they appear to go slow or appear to go fast by virtue of their distance. So, depending on their relative distances, we need to apply now a second correction for the 5 Tara Grahas. Tara Grahas are what we identify as the planets now: Mercury, Venus, Mars, Jupiter, and Saturn. These 5. So they knew that they are also Grahas, they are moving like the sun and the moon. but we need to apply a second correction only for these 5. Now, for explaining this, I would pick up another example of a medieval period which has given the details of calculations. So this is by a person called Ekanatha, who lived in a place called Mahad Nagar here, Mahad. This is the standard meridian from passing through Ujjain and Kanyakumari. No, that's the way it is. But our standard meridians, is slightly inclined to this. And he gives this distance as 30 yojanas, and therefore, what's the longitude correction? And the manuscript that I found in the Bhandarkar Oriental Research Institute there is a copy onto the paper, and it is dated in 1797. But the original text itself is dated 14th century. So using this, we were able to understand the procedure they used for predicting the eclipses step by step, and the method of iterations they were following. All the mathematical details are given in this because it gives a solved example. So, so they start with the year, Shaka year, and then they get the position for a given new moon day or full moon day. And then they apply the corrections for the elliptical orbit, and then the corrections for the location of the observer corresponding to the latitude and longitude on the earth. And when the longitudes are equal, that is the new moon day, or when the longitudes are exactly 180 degrees away, that's the full moon instant, then check the possibility of eclipse. That means they have to find the position of the node also. If node is within a certain degree, then there is a possibility. If it is very far away, there is no possibility of eclipse. So this is the mean path, a circle. After all the corrections, you can see that it becomes an ellipse. So this is the way the correction is applied. And then they calculate the shadow radius. In the case of the moon, we need the shadow radius. So this is a high school geometry problem which is easily solvable by anybody. And they knew how to do this calculation based on the parameters and the instant speeds. So they would know what is the size of the shadow at moon's distance. This is the earth, this is the moon. At the moon's distance, what is the extent of the shadow? And based on that, the speeds, they will find out what's the duration of the eclipse and what type of an eclipse it is, whether it is a partial eclipse or total eclipse. So the example given is 16 January 1367. So this is the position of the moon, this is the position of the sun, and Rahu is somewhere here, very close to it. And therefore there is a possibility of eclipse. So the shadow will be exactly, it's Earth shadow, Earth is here. So if the sun is here, the shadow will be exactly 180 degrees away. So there is a possibility of moon getting into the shadow. So this is the shadow radius, and that's the moon. And so that is the extent of obscuration, which is the same that's calculated nowadays. So now the model which we started for the sun and the moon will now include any planet. So it simply changed the thing to a planet. So instead of 1 month here, it becomes several months, or it's a variable, and they all have corresponding nodes. Every planet will have its own node, and therefore that variability also will be there for the movement of the nodes. Now you can calculate the possibility of any that means Mercury and Venus coming in line with the sun, so you can see whether that is an eclipse or not, or Jupiter going behind the sun. All these possibilities are calculated now. So for this inner planets, let's say I'll take the example of Venus. So this is not 18.6 years, it's something else. So let's say the sun is here, and the planet is here, and the sun is here, let's say. Now, depending on this angular separation, we can predict whether it's going to be an eclipse-like event at all. So that is decided by the angular separation between the two. If it is less than the size of the sun, then there is a possibility that the planet will pass in front of the. This is also an eclipse. Instead of the moon, Venus is going in front of the star. This is called as the transit, and it's a very rare thing. It happens once in 120 years. We had an opportunity to see it in the year 2012. So this is the actual photograph of the event. So you could see that Venus was moving in front of the sun as a dot. And they knew that it was going in a sense which is opposite to the normal motion. And this is because of the relative motion. So why Venus is moving towards west instead of going towards east? That was the question. And if you observe Mars carefully, you will notice that it also goes in the opposite direction sometimes. This is the example of the year 2003. See what is happening? It is moving towards, from Aquarius, it is moving towards Pisces. So it was moving up to here correctly. Here it stopped, took a reverse direction, stopped again, and then proceeded further. This is called as the retrograde motion. And it is known to everybody. All astronomers know this, and even astrologers know this, and they make good money out of this. Why is this happening only for the 5 planets? It doesn't happen to the sun or the moon. Why is it happening only to the 5 planets? This can be very easily explained today by the heliocentric model. So there are 2 stationary points, and it retrogrades. It goes in the opposite sense. And by observing it for all the 5 planets, they knew that the duration is decided by the relative velocities and the relative distance, and the position of the sun is important in this. So you have to involve the relative position of the sun also in the calculation. So it was explained like this in the model. So the planet is going around the Earth in a very funny fashion. So there is a mean path, and on that there is another smaller path, and it is going around in that smaller path. So it appears to go back for a duration. This mathematical model explained it very well, so they were able to predict the retrograde motion very precisely. The heliocentric model explains this very nicely. As you can see here, the Earth is trying to overtake this planet, and when it overtakes it, it appears to go in the opposite direction. This is something you would have experienced on a highway when the vehicles are all moving slowly with different speeds. When you overtake the vehicle next to you, it appears to be going backward. It's the same thing that is happening in the sky. This was the most interesting explanation and puzzle also. And therefore, this heliocentric model explained this very well. And so it immediately became very popular. And it created history in the sense that the next question is why every planet should go around the sun. And that led to gravitation and so on. In the calculations, this is the position of the sun. S is the position of the sun. Here is the Earth. This is planet Jupiter. And so they have, in the ancient text, they have given precisely what should be the value of this angle in order that you see the retrograde motion. So in all the texts, right from say, Surya Siddhanta to the work of Ekanatha and even Chandrasekhar Samanta of 19th century, you will see that these numbers are given. The numbers are like this. So when the planets Mars, Mercury, Jupiter, Venus, and Saturn get a retrograde motion, their longitudes will be 164, 144, 130, and so on. And it stops the retrograde and reverses the direction. At 196, 216, these numbers are given. So the meaning implied is that they precisely knew how to calculate this, although they did not come up with the heliocentric model. In spite of that model, they were perfect in their mathematical rendering. So this is the order of planetary arrangement. This on the text. So you have the Earth at the center, then comes the Moon, then you have Mercury, Venus, and then comes the Sun, and then Mars, Jupiter, and Saturn. This drawing is a little flawed in the sense that the person who prepared this drawing, this is from the internet I borrowed. He knows that Jupiter is a large planet and Saturn also is a large planet, Moon is a small body, and so on. But the model makers here were not aware of the actual dimensions of these. Although they gave some angular sizes, it was not correct. So ideally, this is the model. So all these planets are dots. These are Tara Graha. They look like stars. And the sun and the moon are the only bodies which have some meaningful large dimensions. So this is the model that they proposed. And although they did not write a diagram of this in any book, no book gives you a diagram of this nature. So this model was extracted from the work of Nilakantha in the 14th century or 15th century. So the model is that the earth is here, the sun is going around the earth. They have not put the moon, moon goes around here in a smaller circle. Mercury and Venus go around the sun. So as the sun goes round, these two also follow him. Now you notice that it stops with this explanation. But if you were to extend this, it becomes Tycho Brahe's model. So I complete all the circles here. Earth is here, sun is here. So the sun goes around the earth, Mercury and Venus going around this. And then you have Mars going around here, Jupiter, Saturn, and so on. So you have this as the model, and this explains the understanding. Just one step more will explain it properly like this. So if you extend the orbit of Mars to the dimensions they have given, it is the elliptical orbit with the sun at the center. The same thing for Jupiter, elliptical orbit with the sun at the center. So this is how it is explained. So that means we have a model which is foolproof as far as the mathematics is concerned. But why was the model ignored? There can be many reasons. People forgot about it. That can be one. There were no teachers, there were no takers. So as long as the calculations matched, the order is immaterial. The calculations were perfect. So nobody bothered about what the model is, but the calculations continued. And there were no diagrams in any text. That's the point. And then there are no written records of the discussions or debates, whether people argued saying that this is correct, that is not correct. We will add the elliptical orbit like this. No, we don't have any such written records at all. However, we have to appreciate the logical deduction, which now we understand was meticulously done, and that should not be ignored. So that's where we understand the model of the people here. And I think I have explained how they arrived at the model, and this is a great model. So thank you for the patient listening, and thank you for giving me this opportunity to give the talk here. Thank you.
Thank you, madam. We really learned
Thank
a lot. And
Okay.
hopefully, after we upload on YouTube, on Flame
Yeah.
University's channel and website,
Please send me the link.
I'll
Please.
send you the link. And we really need to thank you for sharing all this wisdom,
thank
and we hope it will really enlighten
Okay.
all people in India and abroad also.
Okay.
Thank you again. Thank you so much.
Thank you.
And we hope to invite you more and more.
Sure. Okay.
Thank you, ma'am.
Can we leave the meeting? Close the meeting?
Yes, ma'am. Thank you. Thank you so much. Yes.